Okay, hello and assalamualaikum everyone. So today we are going to learn about mole concept, something that you've learned in high school. Okay, so mole, mole is equals to mass over molar mass equals to number of particles over Avogadro constant equals to molarity times volume. Astaghfirullahaladzim. Molarity times volume over 1000 equals to apa lagi, volume of gas over molar volume, depending whether it's at STP or room temperature, okay, and pressure. Alright, so for this subtopic, we are going to refresh with a few things that you have learned before and go into newer concepts. Alright, so there's a lot of calculations for this chapter. So our learning objectives for 1.2 is firstly to define the terms empirical formula and molecular formula. So you're familiar with this, and then we are going to determine empirical and molecular formula from first mass composition. Okay, that's one way, or you can also find them by combustion data. Alright, and finally determine the molecular formula from experiments. Okay, so that's the first part of 1.2. Okay, and the second part of 1.2 is we will learn the different ways to measure concentration. Okay, so different ways, that means that it will use different formulas. Okay, there's 5 ways to measure concentration, that they are molarity, molality, mole fraction, percentage by mass, and percentage by volume. Okay, so we're going to go through this part first in this video. Right, so there's 2 types of chemical formula that we learn today. It is firstly empirical formula, where it is a chemical formula that shows the simplest ratio of all elements in a molecule. Simplest ratio maksudnya dia tunjuk dia divide with a number and show the smallest number lah, macam simplest ratio. Okay, so molecular formula is the chemical formula that will show the actual number of atoms. Okay, so if empirical formula does not show the actual number of atoms, but molecular formula will show the actual number of atoms. Okay, so this one here, what I start here is basically from your learning objective. Okay, so before that, we need to know how to find molecular formula from empirical formula or vice versa. So we can use this formula here, where we use our molecular formula equal to our empirical formula times the integer, a positive integer n. Okay, so let's say if we have the molar mass, okay, our molecular mass for a molecule and the mass of the empirical formula, then we can find n. So when we have n, we can find our molecular formula. Okay, so basically you are rearranging this this equation into this equation to find the molecular formula. So let's look at this example down here for different molecules. Let's say if you have hydrogen peroxide as your molecule. Alright, so you didn't know that it was hydrogen peroxide, but you found the empirical formula and your positive integer n, that is 2. So from there, you can do empirical formula times your n, and you will get your molecular formula, which is H2O2. So you know that the molecular formula is for hydrogen peroxide. Okay, so basically you're just using this formula lah to find your molecular formula. Okay, let's go to the first example. That is to find your empirical formula and molecular formula by mass composition. Okay, let's read the question. Ascorbic acid cures scurvy. Okay, it's a penyakit kulit and may help to prevent the common cold. It is composed. Composed maksudnya it is made up. Okay, diperbuat daripada made up of 40.92% of carbon, 4.58% of hydrogen, and 54.50% of oxygen by mass. Okay, so the molar mass of ascorbic acid is 176 grams per mole. So dia dah bagi tahu awak the molar mass of ascorbic acid and the mass composition, okay, of ascorbic acid. Awak tahu each element ada berapa persen, berapa banyak dalam ascorbic acid tu. Okay, so now it asks you to determine its empirical formula and molecular formula. Alright, so the first step what we're going to do when we have the percentage, okay, the mass composition of your elements, okay, your molecule, alright, you will first assume the mass of ascorbic acid to be 100 grams, okay. When you do that, okay, since you are given the percentage ni, you can find the mass. You have values for mass lah, okay. So basically just use the percentage tukar jadi gram, okay. So we're going to draw this special table called Marmora table. Why is it called Marmora? Ma is for mass, mole is for number of moles, and Ra is for ratio. Okay, so this table will help you to find the empirical formula. So let's do it step by step. Okay, so the first row you will write element. Okay, element apa? Inilah yang dia bagi ni, carbon, hydrogen, and oxygen. So you will write your elements first on the first row, and then the second row you will write the mass in grams. Okay, so since we already assume that the mass of ascorbic acid is 100 grams, so we can directly use these values as your mass. Okay, so masukkan je the values, your mass, and then we can find our number of moles. So recall balik, to find number of moles, you can use mass over molar mass. Okay, so here you are putting the mass of carbon and then the molar mass of your carbon. Okay, ini boleh cari dekat dalam table lah. Okay, and then you will get your number of moles. So this is 3.41 mole, right? So make sure bila awak draw this table, you must write the unit accordingly. Okay, if you don't write it here, you have to write it here. Okay, satu-satu. So make sure lah, jangan tinggal. Okay, this is important. Next, you're going to find the ratio of moles. Okay, how do we find the ratio of moles? Now that we have this number of moles for your elements, carbon, hydrogen, and oxygen respectively, we are going to use the smallest number of mole among these three. Okay, so it's 3.41 and 3.41 here. Okay, so we can use that to divide it by itself. Okay, so untuk cari ratio of moles ni, you're actually calculating this way, 3.41 over 3.41, so equals to 1. Okay, so this mole as well, you have to divide it by 3.41 juga. So 4.53 divided by 3.41, and you will get 1.33 for the ratio. Okay, so ratio of moles ni, like I said before, dia samalah macam relative kan. Dia tak ada unit. It is dimensionless. It is only a number. Okay. So this one awak dapat 1 juga. Next, we will find the simplest ratio. Why do we have to do this? Because this number here is a decimal. Okay. We don't want to write our empirical formula, tulis H 1.33. That's weird. Okay. So what you're going to do is you are going to times with maybe the number 2. Okay, test out. And then times with number 3 kalau sampai awak dapat whole number. Okay. So in this case, to find the simplest ratio, we times 1 with 3 times 1.33 with 3 and 1 times 3. So dapatlah 3, 4 and 3 for the number of your elements, carbon, hydrogen and oxygen. Okay. So we get our empirical formula C3H4O3. Alright? Right. So now that we have our empirical formula using this Marmora table, we want to find the molecular formula. So in order to do that, we need to find N by inserting the molar mass of the empirical formula and molecular formula. Okay, so we don't know the molar mass. We know the molar mass of the molecular formula, right? Which is ascorbic acid. But we do not know the molecular formula itself. Okay, awak tak tahu C berapa, H berapa, O berapa, kan? So in order to find that, we need to find N. So using this equation yang I showed you before, we are going to insert the molar mass of, what is this? Your empirical formula, okay, equals to the molar mass of your molecular formula of ascorbic acid. Alright? So when you do that, awak masukkanlah. Ini awak beri keluar supaya dia dekat luar bracket. So ini awak kira molar mass of your empirical formula. Okay. So 3 karbon kali dengan 12.01. Itu dia punya molar mass lah. Okay. So masukkan and then you will find your value of N. It will be equal to 2. Now that we have the value of N, we can find the molecular formula by inserting N into this formula again. Okay, so our molecular formula will be C6H8O6. Alright? Okay, is that clear? Alright, next we are going to find the empirical formula and molecular formula by using combustion data. So why is it called combustion data? So it is when your question sounds like this. 1 gram of a sample of compound A was burned in excess oxygen. So burn in excess oxygen ni is actually a combustion process lah, yielding 2.52 grams of carbon dioxide and 0.433 grams of H2O. Alright, I think I forgot to highlight. So let me just highlight this. Okay. Alright, so what I would do, okay, from this question, I would write down the chemical equation first. Okay, so A was burnt in excess oxygen, okay, to form CO2 and water. Okay, and then I put in the values, the mass of each of the molecule. Okay, so saya letak 1 gram, 2.52 gram, and 0.433 grams for water. Okay, so now determine the empirical formula of the compound. So, the step is almost the same like for mass composition tadi. But it is not given the exact mass composition for your carbon, hydrogen and oxygen. Okay, sebab dia berikan mass of your molecule. So, you must find the mass of your elements, carbon, hydrogen and oxygen. Okay, so dia macam ada one more extra step before you go into Marmora table lah. You use Marmora table ni. Okay, so look here. Ada answer. So, macam biasa, buat elemen, carbon, hydrogen, oxygen. Okay, because those are the elements that we have. And then you write down mass in grams. Okay, so to find the mass of your element carbon, you will use this formula here. Okay, so mass of carbon equals to the molar mass of carbon over molar mass of carbon dioxide. Okay, so maksud ini macam fraction je lah. Okay, untuk dapatkan carbon punya mass times with mass of carbon dioxide. Alright, so ini 12.01 is the molar mass of carbon times with the mass of carbon dioxide, which is 2.52 grams, divided by the molar mass of carbon dioxide, which is 44.01 grams. Grams pula, gram per mole. Okay, so we can find our mass for carbon. Okay, for oxygen pula, okay, kat sini it is 2.02. Okay, why is it 2.02? Padahal satu hydrogen is 1.01 je. Why is that? It is because in water, you have 2 hydrogen atoms. Okay, so aku kena tulis lah. Kalilah 1.01 kali dengan 2. So, it is 2.02 molar mass of hydrogen atoms times with the mass of carbon dioxide, mass of water, which is 0.443 divided by the molar mass of water, 18.02. And so you will get your value. Okay, so to find oxygen, okay, we will just minus from the mass of A, okay, your ascorbic compound A, 1 gram minus with mass of carbon yang awak dah dapat, minus with mass of hydrogen that you count before. And so you will find the mass of oxygen. Okay, kenapa kita tak boleh cari je oxygen punya terus? Kenapa? Because you have oxygen here, you have oxygen here, you have oxygen here. Okay, so it is easier for you to find mass of carbon yang isolated for at carbon dioxide ni saja, and find the mass of hydrogens that is isolated in water saja. Kalau oksigen, awak kena kira untuk dua-dua. Betul tak? Okay, so ini untuk mempermudahkan awak lah. Alright. Okay, so use this step, okay? So next, we are going to do the Marmora table. Okay, mass mole ratio. Okay, so start with your element, carbon, hydrogen, oxygen, and then your mass in grams. Okay, Yang ni ambil je daripada atas tadi. Masuk. And then number of moles is mass over molar mass. Okay. Mass over molar mass. Mass over molar mass. Okay, dah dapat. We will find the ratio of moles. So what did we do to get these answers? Okay, awak pilih mana satu paling kecil value dia. So, kita dapati this is the smallest value. Therefore, you're going to divide all of the moles with 0.01644. Okay? All of this, 0.01644. And similarly for this one. And then you get the ratio of your moles. Okay? So, when you get this, the first step to do is kalilah dengan 2. Okay? So, kalau dah dapat whole number, then you can stop there. If you haven't gotten a whole number, try to times with 3 pula. Okay? And finally, we get our empirical formula. Easy or not? Easy, ah. Okay, so the rest are exercises that... Oh, ada satu je exercise for this part. So, try doing this on your own and we can discuss this during our tutorial nanti. Alright? Okay, bye. Thank you.